Alright, so we are now going to look at solving in a quadratic by factoring, numbers 24 through 27 in your quadratic review packet. For number 24, right off the bat, you should recognize that this is a difference of squares. So therefore, I have right away x and x, square root of 9 is 3, and a plus and a minus. Now, when I multiply those together I get 0, I know that x plus 3 equals 0, or x minus 3 equals 0. If I solve both of those for x, I get x equals negative 3, and over here I get x equals positive 3. So my two solutions are negative 3 and positive 3. For number 25, I first have to subtract 2 from both sides because my quadratic has to be equal to 0 in order to solve it. And now I'm looking for two numbers that when I multiply, I get negative 2 times 3, which is negative 6, and when I add, I get negative 5. Those two numbers are negative 6 and 1, and so therefore now I need to do that shorthand method or factor by grouping, and I take negative 6 and divide it by a, and I take 1 and divide it by a and simplify. The x goes on the bottom, and so I made a little mistake there. Let me erase that. So therefore I get 1 over 3x, and I have my two binomials, which are x minus 2 and 3x plus 1. And again, I know that when I multiply those together and I get 0, either x minus 2 equals 0 or 3x plus 1 equals 0. So solving those would give me x equals 2 or x equals negative 1/3. So my two solutions are 2 or x equals negative 1/3. Okay, if you need to pause it, I will be flipping the page to do number 26 and 27. For number 26, now you have to subtract two things. You have to subtract 7x and you have to subtract 2. So that gives you 15x squared minus 7x minus 2 equals 0. And again, you are looking for two numbers that when you multiply, you get negative 2 times 15, which is negative 30, and when you add, you get negative 7. Those two numbers are negative 10 and positive 3. So now I need to do that shorthand method, which is dividing negative 10 by 15 and 3 by 15, and simplifying the two fractions, which is negative 2 over 3, and again the bottom gets the x, and 1 over 5, and again the bottom gets the x. So that means that either 3x minus 2 times 5x plus 1 either one of those equals 0. So 3x minus 2 equals 0. Add 2 to both sides. Divide both sides by 3. And your one solution is x equals 2/3. Your other solution, 5x plus 1 equals 0. Subtract 1. And divide both sides by 5. And x equals negative 1/5. So my two solutions are 2/3 or negative 1/5. For number 27, this one would be a really hard one to factor because you would use such big numbers. This one is actually a perfect square, and you know that because the square root of 16x squared is 4x, and the square root of 25 is 5. 4x times 5 is 20x, and when you double that, you get 40x. So because you have that pattern, you know that you have 4x plus 5 and 4x plus 5. Now, since this is a perfect square, I know I'm only going to have one solution because I have two equations that are identical. I have 4x plus 5 equals 0, and I have 4x plus 5 equals 0. So I really only need to solve this equation one time, which means I subtract 5 from both sides and divide both sides by 4, and that gives me x equals negative 5/4. I only have one solution to this equation, so therefore I don't need that other solution. This concludes solving an equation by factoring.